A rocket launching into space. A roller coaster hitting 200 kilometers per hour. And a 130-year-old bridge in London. What do they all have in common? One simple principle. By the end of this video, you'll know exactly how it works. Welcome back to Hydraulics A to Z. Let's dive in. If you've watched the first 2 episodes, you already know what hydraulics is and Pascal's law. Push 10 newtons, get back 1,000. Today, we're going deeper. You'll see exactly how a hydraulic system works, step by step. Plus 3 mind-blowing examples at the end. Subscribe if you haven't. Let's go. A hydraulic system is a closed circuit that uses pressurized oil to do work. The simplest way to understand it? Think about your own body. Your heart, that's the pump. Your blood, that's the oil. Your veins and arteries, those are the hoses. And your muscles, those are the cylinders. Every part works together. Remove one, and the whole system stops. Quick intro to every system's 6 main components. First, the reservoir, the tank that stores the oil. Second, the pump, the heart of the system. It pressurizes the oil. Third, the control valve, the traffic cop. It decides where the oil goes. Fourth, the actuator, the muscle, a cylinder or motor that does the actual work. Fifth, the pressure relief valve, the safety guard. It protects the system from overpressure. Sixth, the filter, the cleaner. It keeps the oil pure. 6 parts, 1 mission. Power. Now, the main event. Let's follow a single drop of oil through the entire system. Step 1. Oil at rest. The system is off. The oil sits quietly in the reservoir, stored energy, just waiting to be released. Step 2. Pump starts. An electric motor spins the pump. It sucks oil from the reservoir and instantly pressurizes it. Sometimes 200 bar, sometimes 400 bar. Massive force in a tiny stream. Step 3. Oil travels. That pressurized oil rushes through pipes toward the directional control valve, or DCV for short. Step 4. Valve decides. The operator moves a joystick. A spool inside the valve shifts, and the oil gets directed to one side of the cylinder or the other. Step 5. Cylinder works. Oil enters the cylinder, pushes the piston. Pascal's law multiplies the force. The piston extends, lifting the load. That's the magic moment. That's how an excavator arm goes up. That's how a hydraulic press crushes metal. Step 6. Oil returns. After doing its job, the oil flows back through the return line. It passes through a filter, gets cleaned, then settles back into the reservoir, and ready to do it all over again. A continuous loop of power. But what if pressure suddenly spikes way too high? Pipes burst, cylinders crack, people get hurt. That's why every system has the pressure relief valve. The moment pressure crosses the safe limit, boom, the valve opens automatically and dumps the excess oil back to the tank. Just like that. Physics keeps you safe. That's why hydraulics are both powerful and safe. Now, let's blow your mind. Same principle, 3 incredible machines. First, the SpaceX launch tower. Before that rocket goes to space, massive hydraulic arms hold it perfectly vertical. The moment the engines ignite, those arms retract in seconds. Each arm withstands hundreds of tons of thrust force. Second, hydraulic roller coasters. Coasters like Top Thrill Dragster don't use chains. A hydraulic pump charges an accumulator with insane pressure. Release it, and you go from 0 to 200 kilometers per hour in 2 seconds, faster than a Lamborghini. That gut-punching G-force you feel, that's Pascal's law slamming you into your seat. Third, London Tower Bridge. 130 years old. 2 bascules, each weighing 1,100 tons, lifted by hydraulic rams. The exact same principle you just learned. A rocket, a coaster, a bridge, all running on the same simple system. Let's lock it all in. A hydraulic system is a closed circuit that moves pressurized oil. 6 components: reservoir, pump, valve, cylinder, relief valve, filter. The oil's journey: tank, pump, valve, cylinder, back to tank. That's it. That's how every hydraulic system works. In the next episode, we settle one of the biggest confusions in engineering: hydraulics versus pneumatics. Which one is more powerful, safer, faster? All answered in the next video. Before you go, comment below, hydraulics or pneumatics? Which do you think is more powerful? I want to hear your guess. If this video helped you, hit like and subscribe if you haven't already. See you in the next one. Take care.